Good morning, everyone. A very hearty welcome to all of you back again to this third day of the 3-day faculty development program on environmental management. So today it is my pleasure to invite our guest speaker, Dr. J Brema. Ma'am, thank you for accepting the invitation. So Dr. J Brema has an academic background with BTech in civil engineering and post-graduation in water resource and doctoral degree in civil engineering. And apart from teaching, she has carried out research work and have been published 109 research papers in national and international journals and conferences. Currently, she is guiding 7 doctoral students. She is a fellow of Institute of Engineers, member of Indian Society of Technical Education, member of Indian Water Resource Society, and member of Association of Groundwater Scientists. She is a consultant for hydroecological assessment for integrated management of wetlands granted by GIZ and MOEF and CC. She has published a book on rainfall variation with reference to land use change, Noyal Basin, Lambert Academic Publishing in the year 2017. Her areas of research include wetland hydrology, environmental monitoring, and application of remote sensing and GIS in water resources. Ma'am, thank you for accepting our invitation, and I kindly request you to start your lecture. Ma'am, I'll be giving you the host. You can start the presentation, ma'am.
Yes, thank you for the nice introduction. First of all, I'd like to thank Dr. Rajamurugadas, the director of NSRIT, for inviting me for this lecture, and head of the department and the organizers. Thank you, one and all, for this good opportunity given to me for sharing my experience in a faculty development program. Okay, now I go to the presentation. I assume that the people who are participating here know the basics of remote sensing.
Yes, ma'am.
Am I correct?
Yes, ma'am. Yes, ma'am.
Yeah, so I'm not getting into the basics of remote sensing since people are everybody are learning the as a subject, including the students and all faculty. So I'm directly going to the lecture. Sani, can you see my screen?
Yes, ma'am. It's visible.
Yes, ma'am.
Thank you. Okay, the topic is on environmental monitoring and remote sensing. So this lecture will be on how to use your tools, especially remote sensing tools for monitoring aspect of different aspects of environment. So the outline will go like this. It is some brief introduction about remote sensing, and I am going to deal with 2 ecosystems. How do we apply the tools, and then how to map flood, drought, shoreline change, soil erosion, land use, land cover mapping. This will be the outline of the study. So basically, when you say remote sensing, people first started to say it's with a photographic image, just to see how things are going on, how changes are going on. Slowly, we got into a system where we wanted to see the temporal changes and spatial changes. So we got into more and more of what I can say is different bands. So when we started, especially when I started my work in the year 2003 or something like that, we got only 3-band images. Okay, it was a very preliminary image, like I can say list 3 image with only 3 bands, and then slowly we got into multispectral images where we got 11 bands, 12 bands. So now we are using Landsat imageries, which are multispectral imageries. Of course, I wanted to put a slide to show the difference between this development of satellite imagery. I didn't have time. And then now currently we are working on hyperspectral imagery. Okay, this hyperspectral imagery gives you a lot of provisions to understand what is happening, what are the changes taking place on the Earth's surface. So the differentiation is very easy in case of hyperspectral remote sensing. So this is the era now, and of course we are going into microwave remote sensing, SAR remote sensing. I'm not touching all those things, want of time. So my presentation will be for a period of 50 minutes or something like that. Okay, now just we see an image here. So after all, for all the studies, what is the basis is how we mismanage our earth surface. Okay, so that is what is all about remote sensing. So we want to maintain our resources, we want to manage our resources in a better way so that we don't misuse it. So that is the objective, and that is what is sustainability, what we are talking now. Okay, so you see an image of a particular river in Chennai, which was used for navigation in the years of 1960s, 1970s also. And now it's only a drainage. Nobody can move into this, nearer to this drainage. Such a the smell will be there. Okay, so this was an utility, and now it is not at all in utility. So to understand such things, you can very well use this remote sensing tool, or how far the degradation has taken place, or something like that. Okay, so my first study is on an ecosystem which is situated in northeast state of India. This is Manipur. So we all know it is a state which is developing. Okay, it is like what we can say is the economy of these people who are living here is very less, and their main livelihood is fishing activity and some small activities. Of course, literacy level is high. It is improving nowadays. So what you see here is a lake. It's called Loktak Lake, and just surrounding this, we have got some river basins which are draining into this. So this is a Ramsar site. A Ramsar site means it is a site which is identified with international importance. So it has to be conserved like that. We have got a convention called as Ramsar Convention. Throughout the world, it identifies some places and it tries to maintain the places. Of course, funding is also provided by Wetlands International, something like that. So likewise, this is a identified site of international importance because of certain factors like there is a extinct species, Sangai deer, endangered species. This deer is available only in this particular place, which is living in this particular national park. The significance of this park is it is a floating mass. It's, I can say it's a floating land, and these kumdis are also floating land mass which are used for fishing and where this park is lying. So such a unique ecosystem. Okay, I'm just getting into some of this what is happening here. So what you see here is this floating material, what is present in the national park, has been divided, or we can say it has been cut into pieces, and it is made into circles. And every circle is used for fishing by a particular person. So likewise, they have circles throughout the lake. The total lake area is 230 kilometers square, and out of this whole lake, around 1,200 or something like that, more this type of rings are there. These are called athaforms. Okay, so for this study, we used a remote sensing. How far the park has been disintegrated, how much athaforms have been formed. So because of this, the ecosystem got disturbed. Okay, so now this athaform is spread over the whole, what I can say, the whole lake, and the flow has been restricted. The DO content has reduced. So all degradation factors have got into picture. In addition to that, they wanted to maintain easy transportation. They started living in that floating mass itself. Around 1,000 huts were there in this floating mass itself. So it was something like a floating island. So there was a particular assessment. We went for an assessment. Actually, the project was funded by Planning Commission, and they were given money for making the degradation factors in a better way. That is, this other forms have to be removed, the livelihood has to be improved, like that. So a team from Karunya Institute of Technology and Sciences, we visited there, and we were looking at these problems and how far the problems have been addressed. So if you see, there was a deforestation was there for the purpose of agricultural activities. Okay, they had a specific type of cultivation also, which is called June cultivation. So in that case, what they do is after harvesting, they just burn the land. I think all of you would have heard about this. in north also. So every time during the time of winter, we get a lot of pollution because of the burning of this waste material after harvesting. This is similar to that what I'm talking. Okay, once the material is burned, they shift to the next land and they start growing. And by 1 or 2 seasons, this carbon gets washed away and it is getting ready. Because of this, the siltation was very high. That was one problem. And the next one was domestic sewage was entering into this particular lake through a river, and it is a Nambul River in the north of the lake. And we had a barrage constructed, which was leading to the deterioration of the floating mass. So, of course, when the barrage was closed, water level was high and the floating mass was at a higher level. And this floating mass has to settle down in the land at least for a short period so that it gets the nutrient from the ground surface. So because of this barrage, it was not happening. Okay, so this was another problem, and of course the deer was there, which was in an endangered condition. So with all these problems, the assessment team went there, and we were trying to identify what was the extent of FUMD before the execution of the work and after the execution of the work. So what you see here on the left side is an image of Landsat 2011. Okay, over the image, just we have superimposed this red and green polygons. So we have, in case of remote sensing, raster files and vector files. So what you see here is some part of the vector file. This green color portion represents the thick FOMD and this red color ones represents the floating mass. Okay, it is just moving. Okay, so we to try to assess the quantity. So 2007, this was the quantity. So you can see these green color spots. These are all the FUMDs which are being spread over the lake, and manual and mechanical removal was taking place so that we get a clear water surface, and we got it like this. Okay, when even 3.07 cubic meter of removal was taking place, the environmental flow was maintained. In such a case, only that much water is required, but we are not able to give that much water also because of such a type of mismanagement. Okay, this is one particular example of remote sensing aspect. And the next one was heavy siltation was there in the catchment. So for the every lake or water body, it will have its own catchment area. So this lake, this blue color portion represents the lake portion, and you have got all this as the drainage lines with catchments. So around 7 major rivers were there, and another 3 or 4 small streams were there. And when we took a study, we tried to assess what is the soil loss in these particular watersheds. So whatever soil is getting washed away, it just gets silted up in the lake. Because of that, the capacity of the lake goes off, and the DO content and degradation also starts with that. So when we were trying to do this, we saw that there was a heavy siltation between this portion and this portion. So there was a suggestion for catchment conservation activities. It was nothing but afforestation study. Okay, so the fallow lands what were present in the watershed were converted into agricultural plantation land. Trees were planted so that the soil loss can get reduced. Of course, the catchment area was assessed using remote sensing images, and it was identified. The fallow land was identified. Of course, we have to identify the places which is suitable for afforestation. Such things have been carried out, and you can see some green color portions where the afforestation was done. Around 10,560 hectares were afforested using this method, were identified and afforested. So by means of that, we could reduce the siltation. And again, we have studied the water quality also in this particular lake with some 14 locations, and then spatial mapping was done. Of course, this is not directly based on remote sensing, so I'm not showing that. So later we have got a study on water quality and remote sensing. Okay, so this is one of the ecosystem study what I wanted to explain. And the next one what I'm taking is situated in Tamil Nadu. This is also a Ramsar site, and this is at the end. I can say it is not southmost end; it's the most tip of the this particular portion. This place is called Point Calimere. So very easily you can reach Sri Lanka. The distance is very small between Sri Lanka and this particular place. This is located in Kaveri Delta. What you see here, this triangle, this is the Kaveri Delta portion, and at the fag end of the delta, you can see this ecosystem. Okay, I assume that I can. My voice is audible.
Yes, ma'am, it is audible.
Yes, ma'am.
Thank you. Okay, so what you see here is a wetland ecosystem which has a lagoon, a estuary, and some mangroves, and we have got a sanctuary here. It's a wildlife sanctuary plus a bird sanctuary, and we have got some streams or rivers flowing into this ecosystem. And we have got the flushing activity taking place with the sea also. So I think this is a satellite image, or we can easily see the objects. Of course, it's a cloud-free image. Some clouds are there here, but here it is very clear. So this type of study is quite easy. Ecosystem changes. Okay, otherwise I cannot go for an ordinary like a topo sheet or something. Of course, we started the work with the topo sheet, but I don't have that much frequent topo sheets. Okay, so we used more of satellite images. So in this particular one, as I told, I have all these ecosystems present in this particular complex. So we have got the mangroves here, estuary here, and this is another unique thing which is called as mud flats, where it gets submerged underwater during high tide and it comes down during low tide. And you have got specific species of fish and other things which is living on the mud flat, and a bird sanctuary. Salt pans are there for salt production, and another anthropogenic activity what is happening here is aquaforms. Okay, the cultivation of prawns and all those things. So with this, what happens to this ecosystem? That was our study. So we were given a consultancy work how to maintain this ecosystem, and we try to identify all this, segregate this, or I can say demarcate these portions, so that we can understand what are the changes taking place and what are the disturbing factors here. So when I say the disturbing factors, so the first one is the salt pan and aquafarms. So water was utilized, saline water was utilized, and after utilization, when you say aquaforms, they add a lot of medicines and all those things for the prawns, and that was discharged here. That was one problem, and we didn't have sufficient inflow into the estuary or this lagoon, because it's a highly, this is a cultivated area. Okay, so whatever water they were getting, they were closing the sluice and they were not allowing the fresh water flow into this. So this assessment we made. But of course, when it is during flood time, the sluices will be opened and this area will be completely flooded. Okay, so again, during flood it will be submerged. During summer there will not be sufficient water, and mangroves didn't get optimal salinity for good growth. Another problem was cyclone. The effect of cyclone and tsunami was there. So erosion and accretion was there. We studied that also. Okay, some of the things I'm showing here for want of time. So this was the thing, and we first identified our components like this. So this is a sanctuary portion, and this is wildlife sanctuary. Within this, the reserve forest which is located there. I'm sorry, and this is the mangroves and reserve forest which is located on the leftmost side. So with this, we started our work to identify what are the changes taking place. So normally you call it as LULC, land use land cover change. Okay, so this was the topo sheet. With the topo sheet, we identified the estuary, lagoon, all this, and small settlement was there. And slowly we went into 1990 satellite imagery. You can understand what are the changes taking place. And then it went to 2000. So there were some water spread area increase. From the estuary, it was moving towards the lagoon. These were identified. And by 2010, the estuary was moving towards north and towards east for want of mangrove cultivation. Again, fishing activity was taking place in between the mangroves. So they were wantedly, they were taking canals, fishing canals, and they were cultivating mangroves. So because of that, the estuary was moving. Okay, the estuary was spreading out. And we had some aquaforms springing up here, salt pans springing up here. We identified all those things, and this was in the year 2020. We could see completely the water has started moving this side and it has started merged with the next lagoon. So when we take the water spread area, it was going on increasing every decade. So this is an assessment what you had to do in an ecosystem. The next was we wanted to know what was the flooding in the mudflats. So we took satellite imagery before monsoon and after monsoon. So this what you see is pre-monsoon. I have used a particular index called as normalized differential water index. So you can segregate out your water portion alone in a particular study area using some particular bands. It's called NDWI. So this blue color ones represents the presence of water. So darker the blue color, the depth of the water is high, or you can say it is shallow. So you can see here only this much, whereas post monsoon I have got water here and all. So the mud flats under a submergence. Okay, we calculated the water spread area before monsoon and after monsoon. Okay, and this was done to find out what were the changes taking place on the shoreline. So again, we used this NDWI. This is what I was telling, how to differentiate your land and water. So we used this NIR. NIR is near infrared and SWIR is shortwave infrared. So we have all these bands here. You have to identify which are the brands you are going to work on. For example, if I take vegetation, I will take 4 and 5. If I want to work on water body, I will take 5 and 6, like that. Okay. So this sort of analysis have to be done by the user, whichever thing you is going to make it. So an NEWA was created for the coastline, and you can see we were segregating it only into land and water. Okay, there is no other thing object will be there. So then I can easily find out what is the shoreline, and we try to identify the changes in shoreline. So we could see two lines, 2000 and 2010. So 2000 it is outside, 2010 it has gone inside. So that means I have got erosion at these particular places. What is the length, the level of erosion? You can easily find it out. Okay. Then I go to vulnerability. Okay. In this case, you have to find out which of the places are highly vulnerable and which are less vulnerable. So again, based on this erosion and accretion, we try to identify these vulnerable spots within the ecosystem. So these red spots gave us highly vulnerable points. If just near the mouth of the estuary, you have got two vulnerable points. Okay. Then from 1970 to 2020, what was the changes taking place in land use where we were drying? So water has been water to cultivated land. This has happened in the catchment and in the buffer. Okay, buffer is a distance of 5 kilometers from the ecosystem. Like that, we identified and we drew a buffer line, and whatever changes taking place that was assessed here. And this is the catchment for the complex, direct catchment for the complex. For this particular portion, it goes up to this. So the changes were made, understood like this. Lagoon has been converted to mud flat has been converted to estuary. Again, this sort of study is not easy without a remote sensing tools or something like that. Okay, so because you are dealing with an area of 19,957 kilometers square, this catchment area. Okay, so it was quite easy to do that. Within 2-3 days, we could complete this work. Okay, and this we tried to find out which area, how much quantifying the area. This was carried out. So lagoon was converted into mud flat. 7.24 square kilometer of lagoon is made into mud flat. The water level has gone down, so it is acting more of a mud flat. You can see here mud flat has been converted into mangroves and estuary. Okay, so likewise here also same sort of conversions what it was taking. And then, okay, so this was a part of the study what I am showing you here. Again, then we studied the inflow, all those things. And the salinity, of course, that and all comes in an analytical method, including what I had to say is integrating the remote sensing and analytical method. You can have a very, very good study. Okay, remote sensing can be used as a tool for assessing different aspects. Okay, I go to the next one. This is another shoreline study what was carried out by one of my student on the shoreline of Kerala. We have identified some hotspots. Actually, we did the NDWI and we checked which were the most vulnerable spots, and we identified one of this particular district, which is called as Malappuram district, and that was closely studied. So you can see the shoreline changes. Okay. And for more analysis, she started considering some points. It's called the control points, and these control points will be at a fixed distance. And for these control points, you will be doing your analysis between different years. So you can study whether it has got inside or it has gone outside, that is erosion or accretion, what has taken place. This graph shows us that. Okay, this type of analysis is highly needed when you want to study the changes that takes place in a shoreline, mud banks or something like that which forms, or when I have structures, control structures, how the control structures behave, what is the efficiency of the control structure and controlling the erosion or accretion. So in such cases, we can very well use this shoreline change study. Again, using remote sensing, we can quantify what is the quantity of accretion or erosion that has taken place. So here what we did is we took the digital elevation model of that particular area. Digital elevation model means for every particular point, I will have the raster cell will have an elevation value. Okay, so based on this, and we took the profile of this particular, for example, this is Malappuram district. We took the profile for a period of 1990 and 1970. Okay, so if there is an accretion, the profile would be increasing. So we calculated the volume, the profile minus dem, like that. Okay, that gave us the volumetric changes. So you can see the volumetric changes here. Of course, more of yellow portion was there. It was the changes was very less only. I can say it's of erosion. Okay. And again, in order to study the vulnerability, a land use land cover change model was developed by this particular student based on these categories between the years 2005 and 15. And she could identify that the deciduous broadleaf forest have gone down by 59 percentage. The built up land has gone up by, it is not percentage, it is in kilometer square. Built up land has gone up by 228.47 kilometers square. These were some of the assessment which was carried out. Within a period of 10 years, these changes have taken place. And then we found out based on geomorphology, I have not shown that. Geomorphology means the changes in the coastal area. And based on elevation, we took this vulnerability. And here you can see 2005, my vulnerability is only in this small portion, and here in at some places here. Whereas when it comes to 2015, the vulnerability has increased at these places. Okay, so again, this also has some anthropogenic activities which has got into increase in the vulnerability. Next, I have taken one study on soil erosion. This is done in Godavari Basin, where part of Telangana and part of Andhra Pradesh is covered, and a little bit of Maharashtra is also there. So what we did was we tried to identify what was the rainfall changes taking place between for 4 decades, and what were the changes in land use, land cover, and based on various other factors, and using a particular equation called as universal soil loss equation, we try to identify what was the effect of sedimentation in this particular Godavari basin. So you could see, and I think most of you are familiar with this, and this shows the digital elevation model of the basin. This is what I was talking as DEM. So this yellow color portions or red color portions represents the higher elevation, and you move towards lower elevation, and this is the lowermost elevation, blue color ones. So this is your main course of the river. The drainage lines comes like this. So based on this digital elevation model, the slope of the basin was identified, was estimated, I should say. So with the raster map, we could make this. And then the LULC map for various periods. For every decade it was calculated. So 85 to 2015, I can see the increase in red spots. Okay, these red spots are the settlements. So whenever you say sedimentation or runoff increase or flooding, all this leads to because of impermeability. Okay, higher the impermeability or higher the changes which leads to impermeability, these factors will be going on increasing. Okay, so here we could see here this red spots, that is the settlements. Settlement has increased in a drastic manner within this 4 years in this particular region, and you can quantify your settlement area or all other factors, the cropland and fallow land, everything you can easily quantify. And the rainfall for these 4 years was also obtained: 85, 95, 2005, and 2015. Of course, we don't have any control over this. So we just found out the rainfall for various stations and we prepared a map. The data was given and we prepared this map. We could see this spot is having higher rainfall in most of the time. And this is the soil erodibility. This is one of the important factor for soil erosion. This is a standard data. We had to make it from vector map. We made it into raster map. And the next one is what type of crops are grown in the particular study area. That's called crop cover management factor. So based on the type of crop, you can give some values and you can generate these maps, which is called C factor. And then conservation practice factor, because there is a spelling mistake there. Okay, what sort of management measures we are taking, whether we are having recharge structures, water harvesting structures, this type of thing comes here. Okay, based on the available data, this map was prepared, and integrating all this 5 factors, what I have been telling, the slope, rainfall, C factor, P factor, and soil factor, we could understand what is the soil loss in Godavari Basin. So this is in 85, 95, 2005, and 2015. Again, I'm not showing the table, but during our assessment, we could see there was an increase in erosion. This increase in erosion is because of the land use change. As I have been telling, we have taken 4 years of land use, and from land use only you are calculating 2 factors, C factor and another factor, P factor. So there was a drastic increase of land use on soil erosion, and this 2015 was very high compared to 1985. So what are the conservation measures to be done? This we have concluded in the study. We have superimposed a district map over this to understand which district is having high erosion. Okay. Next, I am going into water quality mapping. How do we, without taking samples or data, how to assess water quality using remote sensing data? So we have done this study in an urban water body, which is located in Coimbatore itself. And it's called Loktak Lake. It's one of the largest water body which is present within the, I can say, urban limits. So these are some of the sample points, these blue points. We have taken some samples for the same day as we get a satellite imagery, so that to correlate the values. Okay, and again we have used the UAV also to get the data, similar data as satellite image, so that we wanted to understand what is the effect of resolution, spatial resolution. So when I say satellite data, this satellite data for this particular Ukadam Lake, I got it from Sentinel-2. It was 10-meter resolution. Whereas I go to this UAV, it gave me a resolution of 30 centimeter. Okay, so you can understand what is the what will be the drastic change, or what will be the drastic change in analysis you can see. So we had a flight plan and image processing. Of course, we got permission from the corporation, and we took, after processing all these images, this was the final image after stitching everything together. So we can see the reflection of the water in UAV images. And this is the processing of the imageries. So satellite imagery was taken and it was processed after atmospheric correction, cloud correction, all those things. And we got this, this is by classification method we identified, and an algorithm was also developed by the research scholar. And based on that, you can see how we can find out what is the DO content, BOD, TOC, and turbidity. This was correlated with the field data. Okay. So if only a particular band for can be used for this. Again, I cannot use all 11 bands at a time. I have to identify band 3 or band 4, whichever is highly suitable for this. And this is based on UAV, with the image what we have taken. So we have tried to correlate with these two, and we had a good correlation between these two. Okay, this is another water quality study which has been taken in Kerala, Vemanad Coal Wetland System. This is another important wetland system in Kerala, where tourism activity is a very big one. And of course, along with the tourism activity, there is the degradation of water quality. They have houseboats here, okay, and so because of that, it's a heavy industry now. During this 1.5 years, it is not there, but still we could observe some degradation. This study was taken in the year, I should say, 18 or 19, okay, before this lockdown, all those things. So again, a spatial mapping was carried out using satellite imageries, and we have derived an image for pH, turbidity, and total hardness. So you can always have the legend whether you want to understand the decrease or increase or something like that. And this was again compared with the values what is taken from the sample. So we could get checked with the standard value. So you can see almost the correlation was good between the two values. Okay. Now I move to mangrove mapping. This is another important one, which is so if I take East Coast, we have got mangroves mostly in the East Coast of India only, on some portions of Tamil Nadu and some portions of West Bengal. A good considerable quantity of mangroves is there. So conservation of mangroves is a very important one, of course, with the frequent number of cyclones, what is increasing and what we are facing, it is highly necessary. So in that case, and another problem in this is identification of species. We have got lot number of species in, if you say this particular study area, what I have taken, there are around 8 species. And because of the changes in salinity and because of the hydrological flow condition, one particular species is becoming less and another species becomes more. Or sometimes as a whole, mangrove goes down, some other invasive species comes up. So in such a case, you can always make a study using some hyperspectral image that is better for such type of species identification. For water quality and species identification, better to go for hyperspectral imaging. Whereas when you want to make a land use land cover analysis, you can go for a multispectral imagery. Okay, so we try to identify the spectral profile of each of these mangrove species. So as I told, I have got some 8 species here: Avicennia marina and Serips decendra, like that. So each of this is having a particular profile. So what is the spectral profile is what is the reflectance in a particular wavelength of that particular species. So this was identified using this our machine learning techniques. We took a lot of imageries and we tried to identify the imageries. We segregated it, and then n-member classification was 10. Based on that, the spectral profile were identified. So you can see before smoothing, this was the raw profile, and after smoothing, how the profile was looking like. Okay, so based on this, you will be doing the classification once again, so that you segregate what is the mangrove area, what is the water area, like that. So likewise, we have just segregated the mangroves, and a little part is there with mangroves and sand. This denotes degraded mangroves. And mangrove mixed means from mangrove it is getting converted into some other form. Like that, you can easily identify which are the what are the changes taking place within a study area. Okay, so these are the steps. From the original image, we get atmospheric corrected image. Then you remove the outliers and then go for a smoothened spectra, then do the classification. Okay, so that was about mangrove mapping. So this is done in Pichavaram, again east coast of India. A similar mangroves is also available in the Ramsar site, Point Calimere. Okay, next, this is another most important study what we have done, flood mapping. So we all know that recently we are coming across many floods. The district of Chennai, Kerala, and I have not taken study in Andhra somewhere. So these two places we have studied, and you can easily assess what is the inundated area with remote sensing tools for after flood and before flood. So we know the reasons for flooding. So that might be heavy reason, many reasons. One might be heavy rain or a breaching of a water body or something like that. Okay. So this is a study taken in Chennai, Adayar River. This river is flowing straight into the corporation itself. And in 2005, 8, and 15, they faced a lot of problem because of the flooding. And again, we all know why there is a flooding in an urban place because of the blocking of sewages and desilting is not taking place, and we have encroached most of the water bodies using our land use land cover change. We can understand all those things. Okay, so this is one of the reasons for the flood what happened in Chennai. So you can see here, this is the red line, it represents the Adayar river basin, and this is our metropolitan development CMA portion. And this river is flowing through this and it gets confluenced at this particular point. This is a delta point. So what we did was, any flood study, we had to make the return period analysis. So after 2 years, what will be the maximum rainfall? After 5 years, what will be the maximum rainfall? Like that. That assessment was made, and we did up to 100 years return period. We have some hydrological equations to do this calculation. So the discharge was calculated. If it is a 100-year return period, it will be this much. So we have to work for this much quantity of water, how to handle this quantity of water. That is the purpose of this hydrographs. Okay. So with that, we try to identify what will be the inundation for various periods of the return periods. Okay. So what you see here is for a 2-year return period, and this is 2 years, and this is for 5 years, and this is for 10 years, and this is for 50 years. Of course, I have not written down the period here. You can see the extent of inundation, what is taking place on the banks. So this is very high. Of course, Chennai airport lies somewhere here where it got heavily inundated because of this 2015 flood. There was no flight movement for a short period. Okay, of course, there is a problem from our side. You can see here, this is the airport area. Okay, where we have identified a wrong place, or mismanagement has been taking place in this. Okay, and in order to understand which location, so any study, when we finally end up, it should end up on administrative boundaries. So when I say watershed wise I work, and I have to put it finally on the administrative boundary and give the results so that the administrators can use it. So we have superimposed to this inundation map for various zones of Chennai, and we were trying to calculate what was the area of inundation for various return periods. So if it is 2 years return period, what will be the area of submergence in Adayar? Adayar is a particular zone in Chennai, so it goes on increasing. As your intensity increases, that is with 100-year return period, the area of submergence also increases. Okay, so this red spots shows the inundated area in various zones. Okay, this inundation study can be done based on your maps directly, taking the water level at various places, and we have some hydraulic modeling also. Based on that, you can do. Or another method, what is available is NDWI. What I was talking about for the coastline, the same thing you can apply for inland also. You can quantify what is the water quantity available inside your study area. It's called normalized differential water index. So this is done for a period of monsoon period. So when it was July in 1993, my water body area was 27.81. But by the time of November, it almost doubles. Okay. Similar is the 2015 also. But for this doubling of water quantity, are we providing the space? That is what is the question. So from 47, my rainfall quantity in 15, it has increased 53.78. For this 7 kilometer square, do we have space to accommodate the quantity of water, or we are going to face floods? Okay, like that you can assess. You can find out the vegetation also in your urban limits. Some studies are there where you can assess your urban heat. What is the changes taking place in your urban limits? What is the temperature change? All those things. There you can study the impact of vegetation also. So this is normalized differential vegetation index. Again, we have tried to find out what is the quantity of vegetative cover within this limit. This is again Chennai only with three different river basins we have taken this. Okay. And you can see here 55.36, by November it is 56. Within 3 months, a small difference is there, but during the periods of years, we can see some drastic changes which is taking place. Okay, this is normalized differential building index. You can identify your building. So this will give you whether there is any increase in impermeability or decrease in impermeability. Again, from 93, 25.366 to 56.608. This is the increase in urban limits, urban expansion within this particular study area. Okay, this is in Kerala. With the 2018 flood we studied, what was the impact of flood in 6 districts. These 6 districts had a severe problem because of the flood. Idiki, Kottayam, Kozhikode, Malappuram, Alappuzha and Wayanad. So with high intensity rainfall, and another impact was due to soil erosion and landslide in the district of Idiki. So we identified these particular districts and we quantified the rainfall, whether it is normal rainfall or it has a lot of deviation like that. Based on that, we identified these districts, and the rainfall was also studied whether there is an increase in rainfall or decrease in rainfall. So you could see here in most of the districts, the rainfall quantity remains the same. In one particular district, it is decreasing, Idiki, and in Kozhikode, it is increasing, but it is not a very high change. But with these small, same type of quantity of rainfall, we are facing flood. Again, we have to identify what is the reason for flood. So it is not due to intensity of rainfall or high rainfall, but there is a mismanagement of rainfall. What is happening? That's what I wanted to be clear. Okay. And this is during monsoon. During the month of June, how much I get rainfall during July. And when we made a study, we could see during September, all this regions got very high rainfall. It is due to the northeast monsoon. Another, so once you understand the rainfall, you can easily identify which antecedent in precipitation index also can be calculated, which may be highly precipitated, highly flooded, like that you can identify. And in case of landslides, you can use this index, which is called as wetness index. As I was telling, Idiki was facing more of landslides. The reason is the wetness increases as your number of rainy days increases. Okay, being a hilly sloping area, and the landslides was very high in Idiki district. So we quantified this topographic wetness index, and we could see this wetness was high in such places. Naturally, when the rainfall is high, these places will experience landslides. Okay. So this is for each of the districts, the wetness index were derived, and the spots which were highly high wetness index were also given and were also estimated. Okay, this is again how much area was inundated. What is the percentage of area inundated? So when I say Kerala, Kerala has got a good disaster management thing, because frequency at which they are facing floods. Now they have got good experience and they have identified all this region wise what is happening. Okay, and next, I think almost I'm coming to the end of my presentation. I'm going to drought mapping. Okay, now we have seen the excess flood and soil erosion, all those things. Now, how do we quantify drought? Okay, so whenever we say drought, it is directly related to agricultural activities, not only agricultural, it is related to any of the watersheds or where you experience less rainfall, something like that. So you can make your analysis using these indices, which are called as spectral indices. So this is vegetation index. We have just used one index, which is called normalized differential vegetation index. You try to identify where there is high vegetation, whether there is changes in vegetation between. So this is 2004 and this is 2009. So of course, this particular area has experienced good vegetation. This is again Chennai district. There is some improvement in land cover in a particular place. Okay, and I think this I covered. I'm just going into the this particular one. So we identified a river basin, Noyal River Basin in Tamil Nadu, and we try to understand how to quantify the health of the vegetation based on remote sensing. So one small watershed was taken, sub watershed was taken in the total thing, and the land temperature was estimated. Whether there is an increase in land surface temperature or decrease in land surface temperature. So this is completely based on remote sensing satellite image. So you will take your satellite image, you will be processing it using this formulas. K1 and K2 constants will be given when you download the image itself. And this L lambda is the image. So using this L lambda, K1 and K2, you will calculate what is the T10. It is called as for the band 10. I have taken band 10, so I call it as T10. What is the temperature? Okay, so based on that, you can calculate what is the land surface temperature, LST10, using the emissivity, how much radiation is taking place on the ground surface. You can, on T10, you can calculate what is LST10, that is land surface temperature. And using this, you can calculate your temperature, whether there is an increase in temperature in your study area. This indices can be used for studying urban heating also, the same LST and TCI. And vegetation condition was studied and vegetation health index was studied. So when you calculate this, you can categorize it like this: extreme, severe, moderate, mild, based on your value. I will just show you some of these images. So this is the land surface temperature. You can see as high as 50.2. It's a summer time and during the month of May 2014. So I can see this much high increase in temperature in these, and this is a hilly area. Okay, so the temperature was very less, 22.54, and you can see the vegetation. This is the vegetation, and as you go down city limits, the vegetation goes down. Okay, water supply in vegetation index, how much it is able to take, or what is the quantity of water it can retain, you can calculate. And this is the type of vegetation what you're having, condition of the vegetation, whether it is in a healthy one or something like that. And health indices. This on the one shows the drought, whether actually your area is under drought, or the soil moisture is decreasing, or you're going to face a drought, something like that, you can easily study. So we can see what are the patches. These patches, you can see how the changes are taking place. The vegetation health is less, and as the water content increases during 17, the vegetation health is better. Okay, so likewise, you can differentiate your area based on all these indices. And you can easily take some watershed conservation measures or something like that to bring down the temperature, to increase the soil moisture, to improve the vegetation health, etc. Okay, so with that, I just trying to summarize my the whole presentation. So you can use remote sensing for any type of mapping. Okay, so we have seen some 8 or 9 applications, and I have covered different aspects also, so that you get different ideas. And in that case, you first identify what is the problem and method. When it's a method, I have to identify the data also. I'm not going to use same type of data for all the things. And please have an understanding about the study area. So if you see, most of my studies will be in Tamil Nadu or Kerala, because I know something or we have to understand something. And in case of remote sensing, ground truthing is very important. So sometimes we may have a miscalculation which will end up into trouble. So always a ground truthing is required. So better understanding of the study area is required, and study the effect of the event, remedial measures, and you can go for future suggestions. Yeah, thank you. With that, my presentation gets over. You can have your questions. I'm waiting for your queries.
Thank you, ma'am. Participants
Yes.
can post the queries in the chat box. I request the participants to post the queries in chat box if they have any.
So
Ma'am, as
you
of
can
now,
have any type of questions. If you want to know something about data modeling or resolution, you can always ask questions.
ma'am, as of now, there are no any queries. So thank you so much, ma'am.
Okay, okay.
Uh,
Thank you, thank you, thank you.
Participants can fill the feedback form. I have kept it in the chat box.
Yeah, thank you for so much for the organizers. I just thank the organizers as well as the management for inviting me for this lecture.
Thank you
Thank
for
you so
accepting,
much.
ma'am. Thank you.
Can I leave? Should I
Yes,
leave?
ma'am. Yes, ma'am. Thank you so much.
Thank you, thank you.
The participants can fill the feedback form. I have kept in the chat box. And I would like to thank all the participants for their continuous patience throughout all these sessions. Thank you all. I thank all of you from on the behalf of Department of Civil Engineering, NSRIT, and our management. And I also want to thank our principal sir and director sir for being a continuous backbone in this session. Thank you all, and thank you very much for keeping your patience with us throughout this session. So the certificate will be sent to you in the next week. We'll email it to you. The session will be live for another 10 minutes. I request all the participants to fill the feedback form.